Next topic is Rutherford scattering or Goldfile experiment. The Thomson explained the model of atom that as atom consists of a uniformly charged positive ion distributed all over the surface where electron embedded at few places, where atom hole is electrically neutral. But when the Rutherford explained Goldfoil experiment, in Goldfoil experiment he did what? He took a source of alpha particles which is contained in a lead container and then a lead collimator alpha particle beam. He targeted this alpha particle beam on a gold foil, a very thin gold foil, say 10 raised to power minus 8 meter thickness. It's quite small. And what he observed that alpha particles are actually what? Alpha particles are helium-2 positive ion. Alpha particles are helium-2 positive ion. So alpha particle is a ray of positive charge particle. So if in the atom positive charge is distributed all over, then each and every alpha particle must suffer equal deflection. But what he observed was surprising result for him. He observed that most of the alpha particle passed straight through the foil without any deflection, where few were deflected by the small angle, and 1 out of 12,000 rebound its path, means retrace its path. The path it was coming, move back along the same path. So this result was really incredible for him. And what he concluded from this experiment, he observed that most space inside the atom is empty, so that's why most of the alpha particle move straight without getting any deflection. And very few deflected by the small angle, it means there is some positive charge occupied at very little place. And but alpha particle which suffer 180-degree deflection, it means it faces a highly positively charged body, so that's why it retraced its path. So from the alpha particle experiment, he observed that at the center of atom, a highly charged, heavily positively charged body is there, that is called nucleus. That body is called nucleus. So according to the Rutherford model, the structure of atom is quite different from the Rutherford. According to the Thomson, positive charge is distributed everywhere where negative charge is embedded at some places. But according to the Rutherford, the structure of atom is quite different. There is a center of the atom which is called nucleus, which is heavily positively charged, and around it orbits are there in which electron revolve, and between this orbit this space is empty. So this is the structure of atom according to the Rutherford, and in this orbit electrons are there. So it also explains few terms like Rutherford scattering formula. Rutherford scattering formula gives the number of alpha particles scattered that is inversely proportional to sin raised to power 4 theta by 2. Means complete scattering formula is this. This is the complete scattering formula with all terms explained here. What is the thickness, what is electron charge, Coulomb's constant and all. But we just have to keep in mind the scattering formula. For your syllabus, you just have to keep in mind the scattering formula. A number of alpha particles scattered is inversely proportional to sin raised to power 4 theta by 2. Two more terms are there. One is the distance of closest approach. I'm just right now telling you what is actually these terms are. Then I will show you their formulas. First, distance of closest approach. What it means? This is the nucleus in the atom. Alpha particle which is moving directly opposite to that nucleus, because this is also positive, this is highly positive or heavily positive, and this is alpha particle. As it is approaching it, according to the electrostatic law, there must be repulsion, and what we observe that as it moving close to the nucleus, its velocity is decreasing. At a point, its kinetic energy changes completely to the potential energy, and due to the repulsion, it changes its path. And the distance up to which it can close to the nucleus, that is called distance of closest approach. This distance here, up to which it can approach, this is called distance of closest approach and denoted by R0. Next is impact parameter. Impact parameter is what? This is the nucleus, this is the central line through the nucleus, nucleus, central line for the nucleus. As alpha particle is approaching to this nucleus, this is velocity vector of this alpha particle, that is v vector. The perpendicular distance of velocity vector from the central line, that is called impact parameter. This perpendicular distance of velocity vector of alpha particle from central line is called impact parameter. It is denoted by B, small b. More this value, less the deflection. More the value of impact parameter, less the deviation of alpha particle. Less the value of impact parameter, more the value of deviation of alpha particle from its path. So this is about distance of closest approach and impact parameter. For the distance of closest approach R0, we have a formula, that is, this is the formula, R0 is equals to 1 by 4 pi epsilon 0 2 times ZE square upon mv square, where Z is the atomic number. We can also write it as 1 by 4 pi epsilon naught ZE square, where E is the charge on an electron, mv square by 2. We can write this 2 upon. This is what? This is kinetic energy. So we can write it as 1 by 4 pi epsilon naught ZE square upon kinetic energy. So from here we can say that distance of closest approach is inversely proportional to the kinetic energy. If kinetic energy is more, then distance of closest approach will be less. This will get decreased, because this is only the kinetic energy which is going to be changing the potential energy and covering a particular distance. So with increase of the kinetic energy, distance of closest approach decreases. And for the impact parameter, we have a formula, that this is 1 by 4 pi epsilon naught Z square cot theta by 2 and half mv square. Just a difference is there. In the case of distance of closest approach, cot theta by 2 was not there, but here cos theta of theta by 2 is here. So this is the formula for impact parameter B. This is the formula for impact parameter B. So there are few drawbacks, like he was not able to explain, as an electron is a charged particle and it's accelerating around the nucleus, then according to the general theory that if a charged particle is revolving, that it must emit its radiation, and with the time it must lose its energy and at last must collide with the nucleus, and atom is not to be stable. But he was not able to explain about the stable structure of the atom. He was not able to explain first of all about the stable structure of the atom. Secondly, he didn't explain about how the electrons are distributed in a shell or the orbits. So These were few drawbacks of the Rutherford model which were overcome by the Bohr's atoms model.